In this video, we're going to be sketching a cubic function. Yeah? Perfect. To sketch a cubic function, you need these 5 things. Firstly, you need the intercept. So you need x-intercept. You need y-intercept. You need to get the extreme points. By extreme points, I mean maxima, and minima. Yeah? Those are the turning points, basically, maxima and minima. Minima. You need to find the point of inflection. Inflection. And then lastly, you need to know the shape before you even sketch it. You need to know the shape of the function. Those are the 5 things we are going to do. Okay. So firstly, I'd like to start with the y-intercept. Let's do the y-intercept. So the y-intercept, remember, we make what? Make x to be 0. Y-intercept, we make x 0. So basically, this x will be 0. So I'm looking for g when x is 0. So I'm looking at g at 0, which means I have to replace all the x's with a 0 that side. And then minus 3, 0, squared minus 4, 0. Then I'm sure, ladies and gents, you can see that the answer will be 0. Therefore, the first point that we're going to use is 0, coordinate 0. Right. When x is 0, the y value is 0. Remember, this is the input. That is the input. And then this is the what? This is the output. Output. Perfect. Now we're going to do the x-intercept. So remember, x-intercept, we do what? We make y to be 0. So remember, we have g of x, as in the question, equals to x cubed minus 3x squared minus 4x. Let me just highlight what we're doing so that we can see what we're left with. So now we're doing the x-intercept. So for the x-intercept, we're going to make the g of x. Remember, g of x is y, so we make it 0, the whole thing. Then here I can see that there's a common factor of x. I'm going to take it out. So I'm going to say, okay, in this case, I'm left with x squared minus 3x minus 4, which gives me a rational trinomial here. This trinomial is a rational trinomial. So I'm going to say, okay, this can be factorized. This guy here is going to be x and x. Then it's going to be minus 4 plus 1. So that the difference is minus 4x plus 1x will give you minus 3x. Now from here, I can split the brackets, right? This is the first bracket. So I can say x equals to 0 or x minus 4 equals to 0 or x plus 1 equals to 0. Then I can see that, okay, this one is already sorted. Here I'm going to have x equals to 4. Here I'm going to have x equals to negative 1. Therefore, my x-intercepts, I'm going to just put them here. Therefore, the first x-intercept is 0 coordinate 0. 0 coordinate 0. That is the first one. Or the second one is going to be 4 coordinate 0. Or the last one is going to be, sorry, let me get this. So the last one is going to be negative 1 coordinate 0. Let's highlight the points because we're going to use them when we sketch. So that is my first point. These are my x-intercepts. These are my x-intercepts. Perfect. Now we need to find the extreme points, which is maximum value and minimum value. which is maximum value and minimum value. Okay, we're going to do extreme points now. So we have g of x, which is equals to x cubed minus 3x squared minus 4x. Then we show here that we're doing extreme points. Extreme points. Sometimes we can say turning points. Ne? Turning points. So turning points, you know that the first derivative of g, must be 0. Always when you do the minimum, the maximum, the highest, the lowest, you are always going to say the first derivative is 0. The turning points, the first derivative is 0. So I need to differentiate that. So the derivative of g of x is basically 3x squared minus 6x minus 4. And then I know that, okay, we said the derivative must be 0 because we are doing the turning point. Minus 6x minus 4. Right. And then here I'm going to use quadratic formula. Therefore, x equals to negative, my b is negative 6, so negative 6. Then plus minus. If you don't know how to use the quadratic formula, please go to the playlist on algebra and check a video on quadratic then. Perfect. So we're going to have minus 6 squared minus 4. Our a is, you can see that our a is 3. So 3. And then minus 4, which is our c. All over 2, our a is 3. Then let's put this on a calculator and see what we get. We just need answers here. Ne? Sharp. So I'm going to say negative, you press the fraction part first. Then you can say negative 6 plus inside the square root. Then we have minus 6 squared minus 4. Our a is 3. Our c is minus 4 over 2. Then 3. And that gives you 2.52. This is your x value in the turning point. Ne? Sharp. And then you can show here that we are doing XTP basically, ne? to remind yourself. Ne? And maybe highlight it like that. So that is the x value in the turning point. Ladies and gents, if you haven't subscribed, please do so. And always like the videos, because the more you like, the more they are going to show it to more people, and the more people are going to be helped. So please, if you like the video so far, don't forget to hit the subscribe and the like button. Thank you so much. So let's proceed. Now we're going to go back there where we put a plus, and then we replace the minus. Ne? We firstly put a plus, then you come back, you remove the plus, you put a minus now. Then everything is still there. Then the other one gives me negative 0.53. Right. These are my x values on the turning points, right? So I need to find f at 2.52. I mean g, remember our function is g. Ne? I need to know what does that give me, and I also need to find g at negative 0.53. So you take these x values, you are going to substitute them into the original function, because remember I said the x values are your inputs. Ne? So you're going to put them on every x value basically. You see it? Sharp. So basically I'm going to say, okay, the first x value is 2.52. So I open a bracket, I say 2.52, and then I close a bracket, I have a cubed, I have a minus 3, I have 2.52 squared, then I have minus 4, 2.52. Okay, let's write this down so that it makes more sense, ladies and gents. So we are going to basically have this. Ne? You see there, you say wherever there was x, you put 2.52, and then you cube it, and then you minus with that 3, and then where you see x, you put 0.52, and then you square it, and then you say minus 4 in bracket 2.52. Then you say or. Right, let's get the answer here. I already put on a calculator. So my answer is 12.83. Okay, we're gonna do the same here. Now we're still writing the same thing, but you are putting a negative 0.53 now. So you have negative 0.53 cubed minus 3, negative 0.53 squared minus 4, negative 0.53. Now let's put that on a calculator and see. Negative 0.53 negative 0.53, and then we put another negative 0.53, and that gives us 1.13. Right, now our turning points, we can see that our TPs are going to be, the first one, it's when the x value is negative 0.53, the y value yields 1.13. Then the second one is this, when the x value is 2.52, the y value becomes 12.83. Then I'm going to highlight this because we are going to use them when we sketch our graph. Ne? So we have the last thing now to get, and then we can sketch our graph. We need to find the point of inflection now, right? Remember the point of inflection? You do the second derivative. So to get the second derivative, you must have the first derivative first. Remember our first derivative was 3x squared minus 6x minus 4. So when I derive that, I'll put 2 lines there to show that I'm doing the derivative of a derivative. Oh, sorry, I forgot to show that we're doing point of inflection. Point of inflection, we know that the second derivative of g of x must be equal to 0. So we know that, okay, second derivative will be 6x minus 6. Then we see that this will be 0 equals to 6x minus 6. I move the 6 that side, then I have 6x remaining. I divide both sides by 6, I get 1 there. Here I get x. So this is the x value on the point of inflection. Perfect. I can show you another trick to get the x value on the point of inflection. Is always halfway between these two x values. Let's see. So you have 0.52 plus negative 0.53. You get the answer. Then you divide that by 2. That gives us, let's see. Oh, we need to subtract them. So it's half the distance. So it's the biggest. 52 minus negative 0.53. Sorry. And then you take that, you divide by 2. That gives you, no, actually that doesn't work. Why? Okay, we'll look at that later. So after getting this x value, we're going to say f at 1. F at 1 gives us, g at 1. I like f of x, sorry, ladies and gents. So we do g at 1. So our function is here. So we're just going to replace those by 1s because there is 1 now. So 1 cubed minus 3, 1, minus 4, 1. Then this give me minus 7, then it's minus 6. Right. Perfect. Then that my point of inflection is going to be 1 coordinate, negative 6. So my point of inflection is, okay, I'll say P of inflection. It's 1 coordinate, negative 6. All right. Sharp. So let's see. Sharp. So, and then we're going to check this now. So guys, we have our points now. Remember, let me just put them closer. So 0.0. So did I leave anything there? Let's see. Oh yes, the shape of the graph. So the shape of the graph, we did point of inflection. That's fine. Let me highlight it. So the last part is to know the shape. The shape is easy. You always check the value of A. Remember, A is 1 in this case, so it means it's positive. If A is positive, it means your graph will start by going up. So your cubic function will be like that. You see, the graph started by going up, then down, then up. So it's like it's going up many times this side and that side. If this was negative, it will start by going down, then up, then down. So I know that in this case, my cubic function will look something like that, right? Perfect. So now let's go and sketch it. So to save time, this is the sketch. We already have the sketch here. We just have to verify if everything is fine. So what you would firstly do, I'll just walk you through it again. This is your first, let's start with the turning points. So this one here is there. Do you see it? And then the second turning point, which is this, is there. But now I'm getting negative 13.13. Why? Let's go check here. Did I make a mistake here? Yeah, this must be negative 12.83. So I think they are the ones who made a mistake of rounding off. So we should be fine there. So here we have we're going to have this. So this is our second turning point. And then it's a negative though, sharp. And then our first x-intercept is 0 and 0, which is also the y-intercept. So it's fine. And then we have 4 and 0, which is there. And then we have negative 1 and 0, which is there, right? And then you join them nicely like this, you see? So what I usually do, I start there on the turning points. I go to that x-intercept. I go to that x-intercept. To make it nicer, I'll do the point of inflection. So 1 maybe somewhere here, and then maybe negative 6 is somewhere there. So my point of inflection will be somewhere here. Do you see it? So you also show your point of inflection. Because I'm using a mouse pad, my sketching won't be nice, guys. But yeah, you're using your pen, so your sketching should be nice. There, and then you go there, you create a nice curve, and then you do that. And you join here in the middle, right? Sharp. And then that's it about sketching a cubic function, ladies and gentlemen. Thank you very much. Aluta continua. Tango.